By this time, you should have tested some of the frequency, bandpass, comb, and cloud filters available on the drop-down menu. You can achieve very interesting results, but if you still feel a bit lost, be sure to check out the last video on this tutorial course for some tips and special features on filters. This drop-down menu is divided in 3 different groups: filters, wave shapers, and modulators. The wave shaper module uses a waveform to shape the input signal. It basically reacts to the amplitude of a given input audio source and shapes it depending on the volume envelope of the oscillator, emphasizing phasing and detuning effects in the signal. You can enrich a signal with harmonics, from subtle density to cutting distortion. Again, you can choose the type of waveform to shape the input signal from the simple, morph, or library wave list. To test it out, let's try to mix a saw waveform coming from the oscillator, shaping it with a basic sine waveform from the wave shaper. The input and output signal level controls allow you to mix the signal coming in and out of the wave shaper before it reaches the master channel. As for the phase control option, it shifts from values between 1 and -1. What this option does is that it sets the phase of the waveform applied in a wave shaper. This parameter has an extreme effect on the outcome result, especially when working with more complex waveforms with several wave peaks and oscillations. The third and final group from the drop-down menu are modulators. A modulator uses a control signal, the modulation source, in order to change a particular factor's value of the modulation target over time. Just like wave shapers and filters, modulators can be inserted in any module slot of the patch window, except in the first row of each channel A to C, and the last slot in the master channel, which is set aside from the master effect module. There are 2 types of modulation available in Absinthe 5, ring modulation and frequency shift. Let's start by selecting the ring modulation first. This function is actually very similar to the ring mod mode available on the oscillator's drop-down menu. The amplitude of the incoming signal and of the signal produced by the modulator are multiplied by one another, creating a more complex waveform with variations on its original cycle. The main panel of this modulator contains that common waveform selector in which you can choose the type of wave to multiply with the original input audio signal. I'll keep the sine waveform at this stage and just try some different waveforms later on so that we can get a feeling of the different results that can be achieved. The frequency drop-down menu enables you to specify the modulator's frequency as a transposition of the played note, as a ratio or relationship with the played note, as a fixed frequency, or also as a fixed MIDI note. As for the balance control, it allows you to mix between the incoming signal when the value is set to 0 and the modulator output when the value is set to 1. For now, I'll just set the value to 0.5 so that we can understand the changes being made when altering these options. It is really up to you to choose how to control the modulator's frequency rate and its balance to get that pulsating effect. Let's test it one more time, but with different waveforms. For the oscillator input, I'll choose a more complex waveform from the morph wave list, for example, analog 1. As for the modulator, I'll choose also a morph wave, but a less curvy one, like this sticky preset here. As you can see, the outcome will really depend on both waveforms being multiplied and the frequency in which they are being generated to achieve that nice pulsing oscillating effect. Let's now return to a more simple waveform on the oscillator and select the frequency shift modulator type. In frequency shift mode, the modulator produces a frequency shift via a feedback loop. It somehow resembles a ring modulator. In fact, you can also achieve similar audio results with both of them. The main difference with frequency shift mode modulation is that while in ring modulation mode, the modulator produces frequency sums, as well as frequency differences. In this frequency shift mode, the modulator limits itself either to frequency sums or frequency differences. So, basically, you get to control the effects on the output result in a more detailed, oriented way. The button that allows you to shift between frequency sums or frequency differences is this button located at the top left of the main panel. When it shows a minus symbol, it means that the modulator is producing frequency differences. When the symbol is displaying a plus sign, that means that the modulator is producing frequency sums. As for both the frequency menu and the waveform selector, they behave just about the same way as the ring modulator, so I'm not going to repeat myself once more. With the frequency shift modulator, instead of a balance control, you get a feedback control. This is because this modulator is acting on a feedback loop. So, with this control, you get to adjust the amount of feedback from 0 to 0.5. Let's now try some examples changing the frequencies between the oscillator and the modulator. This is almost starting to sound like a spaceship engine, like in early sci-fi movies. Let's try to apply a filter over it. As you can see, there are 1,000,001 possibilities that can emerge from different types of waveform sums and modulation. For more examples, please be sure to check out the last video on this tutorial course with some more tips and special features on interesting soundscapes that can be generated through Absinthe 5. That is all for wave shapers and modulators. We will talk about waveforms and spectrum in our next video tutorial.